Okay, rules. Just like, okay, so there's two different rules here. We'll talk about the rules for writing the formulae, and then next we'll look at the nomenclature specific rules. Okay, so the first rules for writing the formulae, you can't just write anything in any order. There's like specific rules that you have to follow. First is the central atom always comes first. So that's why every time we've written it, we have always started off with M. M, then AX, and then square brackets BY, right? So always within a coordinate complex, central atom is always written first. Then if you have like, if it's like a single ligand, if it's like a homoleptic, it's pretty straightforward. But if you have multiple ligands, you need to write them in alphabetical order. And this alphabetical order is based on the formula. Okay. So the placement of the ligand does not depend on the charge or atomic number or anything. It is listed in alphabetical order. Okay, next. So even if it is polydentate, it doesn't have like extra this thing. Everything, whatever ligands are there, all of them in alphabetical order. Then this is quite important. You've seen that every time we've represented it. The formula is enclosed in square brackets. And it needs to be square brackets specifically, no curly brackets, no normal brackets, square brackets only. This is important. Then, but within the square brackets, if you have polyatomic ligands, so polyatomic ligands like ammonia, for example, it's got NH3, or water, H2O. So these sort of ligands and polydentate ligands that you abbreviate, like ligand abbreviations. So whenever you have multiple letters which is not representing an atom, so polyatomic and ligand abbreviations in the sense EN, DPPE, diphenyl phosphethylene, what else? EDTA that we came across. Like all of these will be enclosed in normal brackets. जैसे हमने this A, we put it in like normal brackets, and outside we put square brackets, right? That way. That's what it is. These are again formatting rules. There should be no space between anything between the central atom, between the metal and the ligands, between the ligands themselves. These two are again, you need to work it out. So the charge, like if you're representing a specific ion, like if it's an ionic complex, the charge should be outside the bracket. Should be outside the square bracket. So outside the square bracket, for example, अगर यहाँ पे by नहीं है, so then you need to write it as ma taken x times square brackets, iske bahar you put Y minus. If it is like an ionic complex. But if you have the counter ions also, like if you have both cations and anions, then the charge of the cation or ions, if you have multiple, should be balanced by the charge of the anions. Okay. So suppose like you know that this is the cation and anion is B minus. Then you use that crisscross valency rule. Charge should be balanced. So that's how this becomes By. We'll do a couple of them. You'll get the hang of it. And after that, we'll look at naming of compounds. Okay. All right. If you want, you can write this in short form. This is to remember just for your reference. The main questions is like you need to work out the formula and all. So first question, for example, V is vanadium. So if I ask you to give me the complex formed by V3 plus and 4 water molecules and 2 thiocyanate, इसका formula क्या होगा? What will be the formula of this complex? Right now, like there's no counter ions. Like if the charge is 0, then it's neutral. Otherwise, if it's cations, then you need to put that charge outside the bracket. If it happens to be an anion, you need to put it outside. Okay, so how do you figure this out? Isme metal is vanadium. So this comes, you need to write this first, square bracket, sare square bracket mein. Then 4 H2O and 2 SCN. So H2O and SCN, alphabetically, which one comes first?
We take water only, or
You just look at it. Alphabetically, which one comes first? H or S?
ma'am, H2O will come first.
Huh. And should I write H2O 4 times or should I put brackets here?
Bracket. Ma'am, bracket.
Bracket. Kyunki multiple hai. 4. Then SCN. So this also comes in bracket, 2 of them. Now this is the main thing that you need to work out. इसके ऊपर total charge कितना होगा?
Two plus.
Will it be 2 plus?
Like H2O is neutral. Cyanide has -1. I am not sure. I'm guessing.
There's 2 SCN, no? -1 is correct. There's
Yeah,
2
so -1 and minus. I said +2.
So vanadium पे 3 plus है.
Oh, sorry.
So +3 -2 will be
Yeah,
Plus
1
1.
plus.
plus. Yeah. So this is how you figure out the formula. Next one, CO2 plus and 4 Br minus. So type it in chat. Subscript, it's okay. Like you can just put the number there. But otherwise, I look at brackets, the overall charge, and the like this whole thing. If you're putting the brackets correctly, square brackets, regular brackets, that I'll get it. So in दोनों का send the formula. Once you guys get a hang of it, then we'll look at like naming. Okay. Yeah. Wait, no. So you put brackets for the ligands only if it is polydentate or this thing. Bromine is just atomic, right? So you don't have to put the brackets for that. If it is an abbreviation, bromine is not an BR is not abbreviation of bromine. It's a symbol, no, straightforward. So don't need brackets for that. First, second rules were alphabetical order.
Yeah, so
Okay, so you went by the name ka alphabetical order. That yeah. Name ka. Sanskrit, yeah, first one, yes. Got it. So CO, PR 4. Roman is straightforward, इसलिए no brackets. 4 minus plus 2, overall you'll get 2 minus. Now, इसका, yeah, Sanskriti send it.
yes, ma'am, just typing.
हाँ. NI comes first. So yeah, so Sanskriti when like alphabetical, matlab, you go by the name ka alphabetical. So Dunya ka name is Amin, right? So that comes first and twice. Then Homo and then Cyano and taken twice. Overall, NI is plus 2.
Sanskriti, there is audio for this thing from your mic.
Whose mic is it?
Sanskriti.
Uh-huh. Yeah, this both of you got it. Okay. So one small clarification. Yeah, you can make a note of it. Alphabetical by name. Okay. Okay. Now rules for naming. So if you're given a formula, you have to give the name of the compound. So in this case, it is mostly the same, but you need to, like, for example, we've seen this is a cationic complex, right? Like overall positive charge there. These two happen to be anionic complexes. So most of the things are same for both, but there's like tiny differences whether it's a cationic complex or an anionic complex. Okay. So I'll discuss the difference as and when we come to that point, but just keep in mind that there is a difference between both. The first thing is you start off like the central atom, like cation first. So this is for both cationic complexes and anionic complexes. So when I say cation first, I mean यहाँ पे cation is vanadium, right? So even the complex का name will always start with vanadium or cobalt, whatever the metal complex is. The cation will always come first. Then you start naming the ligands in alphabetical order. Sorry, like whenever you have an overall complex, the cation will come first, anion will come next. Like for example, even for compounds, you've been following this, right? So if you have ammonium hydroxide, NH4OH, you always, even the name ammonium comes first, hydroxide comes second. When you have sodium chloride, the cation is named first, then the anion comes. The anion ka name comes first. So in this case also, where like it may be a cationic complex or an anionic complex, but you'll always name the cation first and then the anion next. So if it's a cationic complex, you'll have cation, like the complex name, and then chloride, bromide, sulfate, जो भी है. If it's an anionic complex, यहाँ पे जो भी cation होगा, like suppose it's a potassium का cation, you'll say potassium and then the complex name. Okay.
Ma'am, I did not understand.
So, like basically, it doesn't matter whether the complex is a cationic complex or an anionic complex. Always the cation is named first. So, for example, if we have a complex, like I'll take this example, okay? Suppose it's a cationic complex, same vanadium, aqua, SCN taken twice, and then Cl. So यहाँ पे you will name the complex first because it's a cationic complex, and then end it with chloride.
Okay.
And if it's an anionic complex, like if I take this example, उसका cation कुछ potassium लगा देते हैं. So this here also cation will come first. You'll name it as potassium, and then the complex का name.
Okay.
So wherever the complex may be, doesn't matter. The format is always cation first, anion next. Okay, just how you write the formula. So cation always comes first. Then, now coming to the complex ka naming, the ligands are listed in alphabetical order. All of them come before the central atom. Okay. Now, isko you have to modify it a little bit. So if you have an anionic ligand, it ends in O. Isliye if you refer to the table, you have fluoro, chloro, anionic or hydroxo. Like every time you come across a negative charge, it always ends in O. That's a rule. If you have neutral or cationic ligands, no change in the name, or you mention the designated name. Like basically, uh, look at the table. Like water will not remain as water; it turns into aqua. Ammonia will not be called as ammonia. It you call it amine. So basically, it won't end in O. Like it will remain as it is, or you use the mentioned name for that particular ligand. Okay. Next, just like with how you mention the position numbers and you indicate how many like substituents are there, here also you add certain prefixes. So prefix like mono, di, tri, tetra. So all of these indicate the number of ligands. इसमें one special case is that like if the ligand name already has the this particular prefix, then instead of using mono di tri, like mono though you won't mention it, but you basically say then use bis tris tetricus. So bis if there's two of them, tris if there's three of them, tetricus there's four of them. So this is like, for example, like this already has a name, matlab diphenyl, like TPP. So if the name already has like diphenyl phosphine ethylene, this is a ligand. So ligand name may you already have di over here. So in this case, if there's two of these, you won't use di, you'll use bis instead of di. That's situation. Then so this is like, okay, you've covered the central atom, you've covered like the ligands. Then mention the oxidation state. So oxidation state of metal, and this also whether it's cationic or anionic, any complex is indicated by Roman number. In brackets. In regular brackets, you also call them parentheses. That's the formal name of those brackets. Parenthesis means round brackets, these brackets. What we discussed, iron 1 oxide, iron 2 oxide. That's not a complex, so simply say iron and then you put the Roman number. In this case, like complex ke baad bracket mein you need to indicate. Now, yeah, this all of these apply to whatever type of complex it may be, whether it's cationic or anionic. Now, this point applies, like now here's a difference of whether it's a cationic or anionic complex. So if it's a cationic complex, then the metal name will be same as whatever that element is. But if it's an anionic complex, then you need to add the suffix ate. And this is something you guys have seen usually, like sulfate, phosphate, nitrate, carbonate. Beside, if it's a complex, the central atom comes in the end, right? So you just add 8 to it to indicate that, oh, that's the anion. If it is a neutral complex, if it's not a cationic complex or anionic complex, same as neutral. So metal remains the same. Metal name. Okay. So these are like different rules with respect to nomenclature. So I'll do a couple of them, like one cationic, one anionic for practice. After that, I'll give you guys a bunch of compounds, figure it out, and then do it on your own. Okay. The first one, suppose I have CrCl2, then H2O taken 4 times plus. So if you go by the rules, it's not a compound, it is simply a cationic this thing. So that's it. Next, the ligands have to be listed in alphabetical order before the central atom. So इसमें what all ligands do you have?
Cl and H2.
हाँ, तो नाम क्या होगा?
Cl will be chlorido and H2O will be aqua.
Yes. So alphabetical, like aqua should come first, then chloro, then Cr is what metal?
Chromium.
Okay. Then anionic ligands, like this name you're familiar with, chloro, and then neutral, matlab aqua is there. Then we need to give it a prefix which indicates the number of ligands. तो इसमें क्लोरो का प्रीफिक्स क्या होगा?
Di.
Yeah. And aqua?
Tetra.
Okay. So the name, if we put all of this together, start with aqua, A. So this will be called tetra.
Aqua, dichloro.
Dichloro, and then the metal. Chromium or chromiate?
Cationic, so chromium.
Chromium. And oxidation state in brackets. तो इसका oxidation state क्या होगा chromium का?
+3.
+3.
Iron.
That's how you put together. Then similar one. Yard.
We have to answer on chat.
If you can do it, yeah, sure, definitely send it. I thought we'll do it together, but if you're confident, yeah, send it out. Sanskriti, let me know if you're attempting this on your own or do you want me to discuss it?
Ma'am, I'm trying it.
Do it. Send it, send it. Yes. Right. This is a lot more easier than your organic naming.
Yeah, this is very simple. I don't like organic wala name. This is
Like it shows in the molecules itself. Organic molecules are twisted, they can be long, multiple functional groups, everything. This is pretty straightforward. You have a central atom, you have like multiple ligands. That's it. You just have to list them one by one. So once you're done with this, one. You have the name for the ligand that I gave in the last one.
Ma'am, could you repeat? I did not hear.
Now I gave like the last one that I asked to name. Do you have the name of the ligand for this? PCH3 taken twice.
No.
Okay. If you want, you can add it to the list. This one. So this is called trimethyl phosphine. And this is abbreviated as right as PP. Uh, emit. Sanskriti, you haven't. You've sent the previous one. ठीक है, आया. So one small correction, Sanskriti, you got it right. Chromium है ना? So anion 8, this becomes chromate. Chromium 8. Yeah. Otherwise, rest of it all, you got it. Smira has sent this. Okay. Oxidation state of cobalt in this Smira. Check that again.
I'm not sure how to do that.
See, suppose I have
The trimethyl thing is neutral, right?
this thing is neutral. Trimethyl phosphate. Okay, so based on that, calculate. If you have aluminium sulfate, formula is this. Isse, can you tell me what is the charge on aluminium?
1+3.
Yes. So based on so figure out the oxidation state on this other thing. It looks exactly like that. No, you have SO4 is taken thrice and this is twice. Like how do you get formula of any cation anion compound? Crisscross one. Sanskriti, what happened? This one